Hello everyone. In this session, we are going to see about what is Carnot Theorem. So my name is P. Induja, working as an assistant professor in the Department of Chemical Engineering, Hindustan College of Engineering and Technology. So in this session, we are going to see about what is Carnot principle, and the Carnot principle involves the following two propositions. So two propositions is nothing but Carnot theorems. So we are going to discuss about that today. So Carnot is nothing but he's an Nicolas Sadi Carnot, who's introduced this concept of Carnot principle in the year of 1824. So we are going to see the next slide. So here we can see the Carnot theorem. So there is two Carnot theorems, which is known as two propositions. So one is no heat engine operating in a cycle between two constant temperature reservoir can be more efficient than a reversible engine working between the same two reservoirs. So you can see the diagram here, so which states that the top of the that is TH, which is known as reservoir at high temperature, and TL is nothing but reservoir at low temperature. We can say high temperature reservoir and low temperature reservoir. In between that, there is two engine, there is heat engine. So one is operating as a reversible engine and another one is irreversible engine. So we are assuming here that the irreversible engine is more efficient than reversible engine. So here you can see the heat engine, that is HEA and HEB. So HEA is nothing but is generalized heat engine, that is HEA, and that is reversible or irreversible, and heat supplied is HEA is QSA and heat rejected by HEA is QRA, and the work output is WA. So you will get the work as WA and WB. So WA is nothing but heat engine A's work output, and WB is nothing but heat engine B is work output. So here another heat engine HEB, that is reversible heat engine, that is second heat engine, which is in green color, and a reversible heat engine can be reversed without changing their values of energy transitions. Here the heat and work interactions is nothing but QSB and QRB and WB. Here the work output of both the engines BW, that is WA and WB. Since the efficiency is defined as the ratio of the work output to heat input, then for engine HEA, both the heat absorbed and heat rejected are less than the corresponding values, that is QRA and QRB for the reversible engine. So in this case, we will say that reversible engine is more efficient than irreversible engine. So the statement is no heat engine operating in a cycle between two constant temperature reservoir can be more efficient than reversible engine working between the same two reservoir. So the statement which says that no engine is more efficient than reversible engine. So this is the first theorem he have mentioned. And next is, so in this slide we can see about the efficiency of the engine A and engine B. So we already said that engine A is nothing but we can consider it as irreversible or reversible. So we are assuming here as irreversible as HEA, and HEB is nothing but reversible engine. So the efficiency of the generalized heat engine will be equal to work output divided by heat input, and for the same in HEB, so the efficiency of the reversible heat engine is equal to work output divided by heat input. So you can see the efficiency for both the engines. So first one, we are assuming that both heat engines are supplied with same amount of heat. So we are giving the heat for both the engines as same. So that is QSA is equal to QSB. that is suction, heat suction, we can assume that S represents. So Q is nothing but heat. So A is first engine and B is second engine. So which both the engines heat are same. So that is QSA equal to QSB. So we are assuming that's first option. Second one is, so the efficiency of the generalized heat engine HEA is greater than the reversible heat engine HEB. So we are considering that irreversible engine is more efficient than reversible engine, we are assuming here. So that means heat engine's efficiency HEA is greater than HEB, which means WA is greater than WB. So work output for heat engine A is greater than work output for heat engine B. So now we can say that the statement is, we already know the statement that heat engine is operating between both the reservoirs, that is high temperature reservoir or low temperature reservoir. We can say that reversible engine is more efficient than any other engine. So here we are assuming that second statement is, we are assuming that efficiency of the generalized heat engine, that is irreversible engine, is greater than reversible engine. So here we can say that the efficiency is defined as, since the efficiency is defined as the ratio of the work output to the heat input, so the engine, both the heat absorbed and the rejected are less than the corresponding values for the reversible engine. So here we can say that a reversible engine is more efficient than irreversible engine. So first we are assuming, and then the statement which has proven that reversible engine is more efficient than irreversible engine. So in this slide you can see the both diagram. So first diagram is which is heat acted as a heat pump. So before slide we have seen that heat engine act as a irreversible engine and reversible engine. Here instead of irreversible engine we are assuming that that is heat pump. So instead of heat engine irreversible, we are considering it as heat pump. So this green color is heat pump, so which is act as a refrigeration. So here you can see that in engine we will get the work output, and in heat pump we will give the work as an input. So here, since a reversible heat engine, that is our HE and our HB, can be reversed without changing the value of heat and work interaction. So this reversible heat engine can be turned into heat pump, which transfer heat from a low temperature reservoir to high temperature reservoir by consuming WB. So work is given as an input to the heat pump. So since we know that WA is greater than WB, so if this is we are assuming some fraction of the work can be used as used to derive the heat pump. Therefore, there is an availability of excess amount of work. So we will see that WC is equal to WA minus WB. So in the second diagram, you can see that so Kelvin and Clausius statement. So Kelvin statement and Clausius statement, which violates both. So here you can see the heat engine which gives the work as an heat output is that heat output is also given to the heat pump as an another source. Okay. So now we will get the WA, WB. So WA minus WB we will get as WC. So that is the second diagram says. So this is what the statement. Coming to the second statement, so second theorem, we can say is second proposition. So second proposition is nothing but all reversible heat engine works between two constant temperature reservoir, have the same efficiency irrespective of the working substances, and this efficiency is dependent only on the temperature level. So the definition itself says that all reversible engine working between two constant temperature reservoirs have same efficiency. So both the heat engine will be acted as a reversible engine. That is, first engine also reversible and second engine also reversible. So if the both the reversible engine is having working between the two constant temperature have same efficiency. So that is known as the second theorem. So we will see the diagram here. So here we are assuming that that QA is equal to QB. The reservoir at the temperature, that is high temperature, can be eliminated. Therefore, if the high temperature reservoir is eliminated, there will be the heat is passing through the heat pump to heat engine directly without having any high temperature reservoir. So here, therefore, the combined heat engine is operating with a single reservoir at a temperature, that is low temperature reservoir, and producing a net work output, that is WC, which means the combined system is violating the Kelvin-Planck statement. So this statement violates the Kelvin-Planck statement, which means that WA is greater than WB is wrong, or the assumption efficiency of heat engine A is greater than efficiency of heat engine B is wrong. So therefore, there will be efficiency of heat engine B is greater than or equal to efficiency of heat engine A. So it implies that no heat engine can be more efficient than a reversible heat engine operating between the same thermal reservoir. So this statement is first statement, and which says that efficiency of HEB is equal to HEA. That is, in this HEA is reversible, and here efficiency of HEB is greater than of efficiency of HEA. Here HEA is irreversible. So here the second theorem, which I already said, that all reversible engine working between two constant temperature have the same efficiency. So that what here given. So the efficiency of the all the reversible heat engine operating between the same reservoir, that is heat source and heat sink. Heat source is nothing but high temperature reservoir, and heat sink is low temperature reservoir, which has same efficiency of heat engine, is independent of the nature of the work substances, that is gas or steam, undergoing the thermodynamic cycle. The efficiency of reversible heat engine purely depends on temperature level of the source and the sink. So you can see the diagram here, and so both the heat engine operating at reversible engine, so which has same efficiency, is known as the second theorem. So finally, I would say that two theorems, that is, first theorem is no heat engine operating in a cycle between two constant temperature reservoir can be more efficient than a reversible engine working between the same reservoir. So this statement says that no other heat engine will be more efficient than reversible engine. And second statement is all reversible engine working between two constant temperature reservoir have the same efficiency. So both the heat engine will be as we will consider as reversible engine. Then the both reversible engines efficiency will be the same. So this is the two statement given by the Carnot. So this statement is known as the Carnot theorem. So that is the theorem statement. So finally, we have learned what is the Carnot theorem. So the two theorems proofs are given in the slides, and I hope you have learned something that about Carnot theorem. And Carnot principle is nothing but all the engines will be in reversible engine, which has isothermal heat absorption and adiabatic expansion, and also isothermal heat rejection and adiabatic compression. So these are the Carnot principle statement. So thank you.